Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on measures of central tendency and measures of variability. In previous grades, you studied the mean, the mode, and the median of data sets. These are measures of central tendency. You also studied measures of variation, including range, variance, and standard deviation. Today, you will learn other measures of variation, such as mean deviation and interquartile range. We have a lot of material to cover today, students. So, let us begin. Mean deviation is the sum of deviations in absolute value of each item from the average divided by the number of items. Today, we will learn how to calculate mean deviation for ungrouped data, for discrete frequency distributions, and for grouped data. Firstly, let us look at ungrouped data. Here is the formula for finding the mean deviation about the mean. It is the sum of the deviations of each item from the mean divided by the total number of items. To find the mean deviation about the median, use the median in place of the mean and proceed the same way. The mean deviation about the mode is calculated in the same manner. Next, we will learn how to calculate the mean deviation for discrete frequency distribution. Discrete data is data such that each and every one of the observations is described by exact value. To find the mean deviation, we must follow these steps. Find the mean of the dataset. Find the absolute deviation of each item from the mean. Multiply each deviation by its corresponding frequency. Find the sum of these deviations multiplied by their frequencies. Divide this sum by the sum of the frequencies in the dataset. Students, based on this information, find the equations for the mean deviations for discrete frequency distribution? Please write down your answers.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I am sure you did not find this too difficult. Your equation for finding the mean deviation about the mean should look like this. To find the mean deviation about the median and mode for discrete frequency distribution, we simply substitute the median and mode for the mean as we did previously. These shortened equations use the Greek symbol sigma for sum. For grouped frequency distributions, we do not use individual data values. Rather, the values are presented in classes. For example, our data table would show a range of values instead of one value. Therefore, to find the mean deviation for grouped distributions, we use the midpoint of each class, represented by M, rather than an X value. For the mean deviation about the mean, our equation looks like this. It is the same equation for the mean deviation about the median and mode. We simply substitute median and mode for the mean. Students, let us try an activity. Using this table of grouped frequency distributions, please find the mean deviation about the mean.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Welcome back, students. Did you remember all of the steps? The first step is to find the midpoint for each class. The first class is 0 to 5. So the midpoint is 2.5. Fill in the values for each class in the same way so that your table looks like this. The next step is to find the mean. Multiply each midpoint by its frequency and divide this by the total frequencies. The mean of this data set is 13.88. Next, find the deviations about the mean by subtracting the mean from the midpoint values. Remember that all of these deviations have absolute values. The next step is to multiply the deviations by the frequency. When we add these numbers together, we get 166.34. The total deviation about the mean divided by the total frequencies is the mean deviation about the mean. When we substitute our values, we find that the mean deviation about the mean for this frequency distribution is 5.74. Good work, students. Mean deviation is not commonly used for statistical interpretation because it can be affected by extreme values. Also, by taking absolute values of deviation, it violates the rules of algebra. However, it has an advantage over the measures of variation that we will be looking at next. Mean deviation takes each value into consideration, whereas range and interquartile range only consider two values. Recall students that the range of a data set is the difference between the highest and lowest values. Range is highly affected by extreme values. It might be more useful to measure the difference between the third and first quartile. This is called the interquartile range. Students, before we discuss the interquartile range, let us quickly review how quartiles are determined. Remember to always arrange the data set in ascending order. To find the kth quartile of ungrouped data of sample size n, we can use this formula. For class size n equal to 5, we can use this formula. x1 plus 0.5 times x2 minus x1. x1 is the first number in the set, and x2 is the second number. To find the third quartile for a sample size, we can use this formula. x4 plus 0 plus 0.05 times 5 times 5 x minus x4. X4 is the fourth number in the set, and x5 is the fifth number. Consider these two sets of data. The first set is 3, 5, 9. The second set is 3, 4, 6, 8, 9. The range of each set is 6. But you can see that the second set is more variable than the first. Let us use the interquartile range and see if we get a different result. For A, the first quartile is the integer at the position of 1.5. To find the first quartile, we add the value of x1 to the difference between x2 and x1 multiplied by 0.5. By substitution, we find the first quartile to be 4. The third quartile is at the position of 4.5. This time, we add the value of x4 to the difference between x5 and x4 multiplied by 0.5. By substitution, we find the third quartile to be 7. The difference between the third and first quartile give us our interquartile range, which is 3. Since our data sets have the same number of integers, we will find the quartiles in the same way. For B, the first quartile is 3.5, and the third quartile is 8.5. The interquartile range is 5. Since the range is higher for the second set, the data is more variable. As we said earlier in the lesson, one limitation of mean deviation is that it violates algebraic rule by using absolute values. One way to counteract this is by using standard deviation. You may recall that standard deviation is given by this equation. Since the deviations are squared, the values become non-negative without violating any rules. This makes standard deviation the best measure of variation. The greater the standard deviation, the higher the variability. We have learned a lot today, students. We have learned how to find the three mean deviations of a given data set, and also how to calculate interquartile range. Please practice the additional exercises in your text to ensure that you have understood the material. Until next time, thank you, teacher. Thank you, students.